Hello students. So this is part 2 of our physics first chapter, class 11th. Dimensional analysis is the name of the topic and the name of the chapter is units and dimensions. So in the first part I discussed about what exactly is dimensional analysis. So dimensional analysis is basically a category where we use dimensions to carry out certain operations, and these are categorized into three different sections. The first one is to check a formula. We can check a formula using dimensions and figure out कि वो dimensionally correct है या नहीं. Second application is to derive a formula. Based on the parameters given, we can deduce a particular formula. And third is to convert from a given system to another system. So the given system can be any FPS, MKS, CGS, SI system, and the another system can be any as well, and it can be a new non-existent system also with certain parameters. But in this particular video, we are only going to discuss the first application and we will be solving some questions on the same, which is to check a formula dimensionally. So we will start with Einstein's mass energy equivalence. So we will be checking Einstein's mass energy equivalence, which is E equal to m into c square, the most important equation in physics, which even apart from science students, other students are also aware of, which is E equal to mc square. Here E is energy, m is the mass, and c refers to speed of light in air, which we all know has the value 3 into 10 raised to power 8 meter per second. So how are we supposed to check a formula? Now the best way of doing so is to find the dimensions separately for LHS and for RHS. So what I will do is, I will start with LHS. In LHS I have energy. Now we all know that energy equals work, and work is nothing but force into displacement. Moving ahead, we know force is mass into acceleration. So we get a simpler formula, mass into acceleration into displacement. Now writing the dimensions of mass, we have m raised to power 1. For acceleration, we have the unit meter per second square. I told you meter means L raised to power 1 per second square, that means T raised to power minus 2. For displacement, the unit is meter, so m raised to power 0, L1, T0. Now we will combine the parts. We get m1 plus 0 plus 0, m1, L0 plus 1 plus 1, L2, T0 minus 2, 0, T minus 2. This is our LHS. Now we will move to the RHS. So when we talk about RHS, we have m into c square. So for m, which is mass, we have m1, L0, T0. C is the speed of light, be it any speed. The unit is going to be meter per second. Likewise, the dimension is going to be for meter L1 per second. Whenever we have the word per, the power becomes negative. And square. So the power gets multiplied inside. 0 multiplied by 2 gives 0, 1 into 2, 2, minus 1 into 2, minus 2. I will combine both yet again. It becomes m1, L2, T minus 2. Now you all can clearly see that from LHS and RHS, they both come out to be what? Equal. So we will write, since LHS equal to RHS, the formula is dimensionally correct. Next, I'll be checking the first equation of motion for you as the second example. We all know that the first equation of motion is V equals U plus AT. Here V stands for final velocity, U stands for initial velocity, A is the acceleration, and T stands for time. So we'll start with LHS. LHS has V. V is final velocity. Now as I discussed, be it any velocity, unit रहेगा मीटर पर सेकेंड. सो मीटर के लिए डायमेंशन हो गई L1, पर सेकेंड के लिए it becomes T minus 1. Moving to RHS, we have U plus AT. So for U again is velocity, so same आएगा m0 L1 T minus 1 plus acceleration has the unit meter per second square. So for meter it is L1, for per second square it is T minus 2 into T, time, for time m0 L0 T1. So multiply में जब बेस सेम होता है पार्स ऐड होती हैं, so it becomes m0 L1 T minus 2 plus 1 is minus 1. And here I have to discuss a very important point, which is principle of homogeneity, which says like terms gets added into like terms. So like plus like equal to like, and like minus like equal to like. This means whenever we add any two dimensions, we never use the number 2 because numbers have no role in dimensions. Likewise, when I subtract two similar dimensions, my answer is not going to be 0. So this means I will not write it 2 times, I will simply write it once, m0 L1 T minus 1. Again, from LHS and RHS, we see that they both are equal. So the formula is dimensionally correct. So you all have to memorize that whenever we frame dimensional formulas, we never use numbers. कभी भी हम numbers को use नहीं करेंगे. And your task is to check second equation of motion, which is s equal to ut plus half at square. So उसमें half का कोई भी significance नहीं है. And second most important thing is that when we add similar dimensions, it does not become 2. We do not use the numeral 2, and when we subtract two similar dimensions, it does not become 0. We still have to write it once. I hope you will listen to the video pretty carefully and try solving the questions. See you in the next video. Thank you so much.